In this next example for section 10.4, we're actually going to jump to the most complicated multiplication problems. So we're kind of going from ones that are a little more simple and straightforward to the ones that are going to take the most amount of steps. And then we're going to land kind of for our last couple of examples somewhere in between. So in these examples, we are going to work through and we're going to multiply a binomial times a trinomial. So remember, a binomial has 2 terms and a trinomial has 3 terms. So since our binomial has 2 terms, what we're going to do is we're going to use our distributive property twice. We're going to distribute each term of that binomial. Right? And as we're doing that, again, just like we have, and then we're going to continue to do in this section, right, we are going to multiply our coefficients and add our variable exponents. All right, so in this example, example 4, we're going to multiply a binomial times a trinomial. Again, we're using our distributive property twice. And what I'm going to do is I'm actually going to work through the exact same problem 3 different ways. This means that as you're going through, there's a couple of these in the homework. There's not a ton, but there are a couple. As you're going through these, you don't necessarily have to do the same problem 3 times, 3 different ways. Right? Pick your favorite way. Maybe try each way and decide kind of what your favorite method is. Right? So our first method that we're going to use is going to be our double distribution method. Right? So we have a binomial, 2x plus 3, and we are multiplying it by a trinomial, 6x squared plus 4x plus 5. So we're going to start by distributing that 2x. So the first thing I'm going to do is I'm going to rewrite my problem. Right? So we're going to end up distributing that 2x to that entire trinomial. Once we're done doing that, we're going to distribute our other piece of our binomial, which is a positive 3, to our trinomial. So I'm going to put a plus 3 out here, and then again I'm going to write the same trinomial, 6x squared plus 4x plus 5. Right, so here we see we actually are going to be using our distributive property twice. All right, now I'm going to go ahead and do the multiplication. Unlike the previous example, I'm not going to draw in all of the arrows, right? But we're thinking about all of these little invisible arrows to do our multiplication. Right, 2x times 6x squared. Well, 2 times 6 gives us 12. We add our exponents. 1 plus 2 gives us x to the 3rd. 2 times 4 gives us 8. So we're going to have plus 8. Our exponent for x, 1 plus 1 is going to give us 2. Right? And then 2 times 5 is going to give us 10, and that's going to have an x. Right, now I'm going to distribute my 3. Again, we're thinking about this. There's little invisible arrows going to all 3 pieces of our trinomial here. 3 times 6 is 18. Right? We're not changing our exponents here because 3 does not have a variable piece to it. So that's going to stay x squared. 3 times 4 is 12, and that's going to stay in x. 3 times 5 is 15. Now, whenever we're working with polynomials, we want our answer to be in simplest form. Remember that simplest form means that we have the least amount of terms. So looking at this particular answer, we do have some like terms. So what we're going to do is we're going to go through and combine our like terms. Right? As we're doing this and as we're writing our answer, we're going to make sure we write it in descending exponential order as well. So our first term is going to be this 12x cubed. Then we have a couple of x squared terms. So 8x squared plus 18x squared is going to give us 26x squared. 10x plus 12x is going to give us a 22x. And then we have our constant term that's coming in as our last term is a plus 15. Okay. So we started by distributing our binomial to our trinomial, and our answer started with 6 terms. And then we combined the like terms that we could, and we ended up getting an answer with 4 terms. Depending on the type of problem you have, you may keep 6 terms. You could end up with an answer that has 4 terms, 5 terms. It just kind of depends on the original binomial and trinomial that you start with. But you just want to make sure that in the end, we combine those like terms if possible. All right, now in the second method, we're going to set this up so that it looks kind of like a normal multiplication problem. Again, we're going to go through the exact same problem, exact same numbers, and show that no matter which method we use, we should get the exact same answer. So just like we would do with normal multiplication. You know, if I was multiplying 253 times 42, I would set up a vertical multiplication problem with one number on top of the other. And generally we put our larger number up top. We're going to do the same with our polynomials here. So I'm going to start by rewriting my problem as 6x squared plus 4x plus 5, right? And then underneath that, 2x plus 3, right? And we're going to put a line under there just like we would with normal multiplication. You can put a times sign over here, but a times sign looks like an X, so I usually just leave it out to prevent any other extra confusion. And just like we would with normal numbers, right, we're going to start with this number and this number. We start with normal numbers are ones column. Well, we're going to start with our constant terms. Well, 3 times 5 gives us a positive 15. And I am going to go ahead and leave my signs in front of these. In this particular problem, it's all positive numbers, so it's not that big of a deal. But if you are working with other polynomials, you will see negative signs in there. So I strongly recommend putting your signs in front of each individual term as we're going through our multiplication. Right? 3 times 4x is a positive 12x. 3 times 6x squared is a positive 18x squared. Right? Again, the 3 didn't have any variable parts, so we're just multiplying our numerical coefficients. Now that we're done multiplying with the 3, we're going to multiply everything by the 2x. So 2x times 5 is going to give us a positive 10x. 2x times 4x is going to give us a positive 8x squared, right? Because 1 plus 1 is 2. 2x times 6x squared is going to give us a 12x to the third. The nice thing about doing this, and I just kind of did it automatically without mentioning why, notice that I lined up all of my like terms in this second product. Right? So I didn't have anything that was a plain number that went with that, so I started my 10x underneath my 12x. And then my 8x squared I put underneath my 18x squared. So the nice thing about these, instead of searching through a long list of terms looking for like terms, we can nicely and easily line up our like terms as we go. Alright, so we have a positive 15, 12x plus 10x is a positive 22x, 18x squared plus 8x squared is a 26x squared, and then a 12x to the third. Right, when we're combining like terms in this last step, remember we're not changing our exponents. We're just changing our exponents in the 2 steps where we're actually doing the multiplication, right? That green and that blue product that we have there. Right? Notice that we get the exact same answer for both of these problems. We just arranged our work a little bit differently. Again, you don't have to do the exact same problem 3 different times as you're going through the homework. We're just giving you a few different ways. Right? Then for our final method. Our final method is sometimes referred to as a box method or a grid method, square method, something along those lines. What we're going to do is we're going to create a little box or grid that's going to have 6 squares in it. Right? We have 6 squares because we have a binomial, okay, and a trinomial. So what I'm going to do then is I'm going to label my 2 different pieces. So my binomial has a 2x and a positive 3, and my trinomial has a 6x squared, a 4x, positive 4x, and a positive 5. Right, now what we're going to do is we're going to go through and multiply. Right? We're going to multiply using the 2x first. So 2x times 6x squared is going to give us 12x cubed. 2x times 4x gives us a positive 8x squared. If you want to write the positive sign in there, you can. If it starts to get a little too cramped, you can leave it out. 2x times 5 is going to give us a 10x. Right, I'm just going to leave out the rest of our positive signs. Again, if you're dealing with negatives, make sure you get those in there. 3 times 16x squared is going to give us 18x squared. 3 times 4x is 12x. 3 times 5 is 15. Notice that in this case, our like terms end up lining up diagonally. It doesn't always work that way, but in this case it does. Again, it depends on your original polynomials that you start with. Right, so our first term is going to be 12x cubed. We're going to combine these two x squared terms to get 26x squared. Combine these two x terms to get a plus 22x, and then we finish it off with our plus 15. So as we go back and we look at these three different methods, notice that we get the same answer in each different problem. Again, it just kind of depends on what the easiest way is for you to write out your problem and organize your problem. Again, if you do have negative numbers, watch those negative signs. Remember that what we're thinking about here, we're using our distributive property twice because we have a binomial out front. And as we're going through and doing this, we're multiplying our coefficients and adding our variable exponents.